This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 4, Fan Selection and the Operating Point. A fan does not deliver a flow you choose. It delivers wherever its own falling pressure curve crosses the ductwork's rising system curve. That crossing is the operating point. We'll read both curves, see how the point rides the system parabola when the flow changes, and compute the fan's air power right at that point. Concept 1. 2 curves, 1 point. Selecting a fan overlays 2 facts about the same air. The fan curve is what the fan can produce, and it falls as flow rises. The system curve is what the ductwork demands, and it rises as flow rises, following pressure proportional to flow squared. The fan can only run where those two meet. 1 flow, 1 pressure. That crossing is the operating point. Concept 2. The operating point on the plot. The blue fan curve falls, the orange system curve rises. Left of the crossing, the fan makes more pressure than the duct needs, so flow speeds up. Right of it, the duct needs more than the fan makes, so flow decays. Only at the crossing do supply and demand balance. Drop the point down for the delivered flow and across for the delivered pressure. Setup. The system law. The handbook states the system curve directly. The pressure ratio equals the flow ratio squared. A parabola through the origin. Change the flow and the operating point moves along that parabola. Cut flow to 80% and the same duct needs only 64% of the pressure. Slowing the fan is what lands you there. The point slides down the same curve to a lower flow and a lower pressure. Setup. Fan power in 3 levels. Air power is the constant times flow times pressure, with flow in cubic feet per minute and pressure in inches water gauge. Divide by fan efficiency for shaft or brake power. Then inflate for drive and motor losses to get the motor input. The handbook gives no typical efficiency or loss values, so treat them as problem givens. There's also a small temperature rise across the fan, and note its capital CP is a unit constant, not the lowercase specific heat. Solve. At the design point, 10,000 CFM and 3 inches water gauge, the air power is 4.71 horsepower. Turn the flow down to 80%, 8,000 CFM, and ride the system parabola. Pressure drops to 3 times 0.8 squared, 1.92. Air power at the new point is 2.41 horsepower. Cross-check the ratio. 241 over 471 is 0.512, which is 0.8 cubed. The cube falls right out of the parabola and the power law. Traps. 5 ways this bites. 1. The fan runs only where both curves cross. Read the point off the intersection, not the catalog rating. 2. Reducing flow is never horizontal. Slow the fan and you slide down the same parabola. Close a damper and you build a new steeper curve and ride up the fan curve to higher pressure. 3. The air power constant needs flow in CFN and pressure in inches water gauge, nothing else. 4. Air power is not shaft or motor power. Every step after it needs an efficiency. 5. Capital CP is a unit constant. Lowercase cp is specific heat. Quick recall. The operating point is where the fan curve meets the system curve. 1 flow, 1 pressure. The system law makes pressure track flow squared, a parabola. Air power is the constant times flow times pressure in CFM and inches water gauge. From air power, divide by fan efficiency for shaft power, then account for drive and motor losses. And the golden rule, throttling a damper rides up the fan curve, slowing the fan rides down the system parabola. Next up, Lesson 5, Air Distribution. Now that we've moved the air and paid for it, we deliver it to the room comfortably. We'll read the characteristic room length by diffuser type, the ADPI selection guide that targets a throw ratio to maximize comfort, and the recommended return inlet face velocities. It's a table read lesson. The handbook gives selection guides, not a throw equation. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.